Hello everyone, myself Sravanthi working as an assistant professor in MLR Institute of Technology. Today our topic is handle and handle pruning. The overview what we are going to discuss in today's definition of handle, what is handle pruning and what is sentential, what are the types of sententials and the examples of it. So what is a handle? Handle is nothing but the substring that matches the body of a production. Handle is nothing but the substring that matches the body of a production. Handle reduction is a step in reverse of a rightmost derivation. So, handle is nothing but, for example, I'm having some sentences. I'm having some sentence. In this sentence, a substring is nothing but some symbol or a string. This is my string. In this string, the substring, if the substring is matches to the body of the production. So, this is my grammar. Suppose some grammar productions are there. E tends to, F tends to. These are my grammar and this is the grammar and these are my productions. If the substring matches to the body of the production, that is nothing but we are going to call it as a handle. We are going to call it as a handle. When we are constructing a parse tree, this is nothing but bottom-up parser is nothing but we are going to construct a parse tree. When we are going to construct a parse tree, the handle is the portion of the input string that has been marched. Okay, it can be reduced to a non-terminal symbol according to the production rule. So, here handle is nothing but the substring which is matching to the production. If that substring is matched to the production which is present in the rightmost derivation of a production, then that production is replaced with the LHS part of a non-terminal. We are going to reduce the production. So, that is nothing but we are going to call it as a handle. In the last class, we have discussed about a shift and reduce. So, we are going to shift these to the stack. Here, we are going to just handle that. And the next, if it is found, we are going to reduce it. Reduce the production. So, this is about a handle. Next, what is handle pruning? Handle pruning is nothing but it is also used in the shift and reduce parsing. Removing the children of the left hand side non-terminal from the parse tree is called handle pruning. So, handle pruning is nothing but we are going to remove the children. So, nothing but this is a sentence. A sentence consists of the terminals, nothing but the leaf nodes, nothing but the children. Terminals will be there. So, these are going to be replaced with the non-terminals. We are going to replace it with the non-terminals from the parse tree is called as a handle pruning. Is called as handle pruning. We are going to remove the children. Okay, a rightmost derivation in reverse can be obtained by handle pruning. So, here I am going to derive it id into id. So, nothing but in the last class we have derived id tends to f and next f is nothing but t, it is reduced. The next it is going to be reduced f. So, the t star f can be reduced to t can be reduced to e. So, this is nothing but the bottom-up parser. It is nothing but bottom-up parser. Now, these if I apply it in a reverse manner, we are going to call it as a handle pruning. A rightmost derivation in reverse manner. Same thing we will see here. E tends to T, T tends to T star F, F is reduced ID, next star, next it is reduced T, T tends to F, T tends to F. F is nothing but again it is reduced to ID. So, see here, when a rightmost derivation, for this bottom-up parser, when I am going to apply the rightmost derivation in reverse manner, so this is nothing but we are going to call it as handle pruning. We are going to apply it with a reverse manner. That is nothing but handle pruning. And rightmost derivation, see here, first I am going to derive the right part and then I am going for the left part. Once I complete reading the right hand side, then I am moving to the left part. So, this is nothing but we are going to call it as handle pruning. See here, removing the children of the left hand side non-terminals. Okay, so we are going to remove the children's or we are going to find the terminals. So, nothing but it is a handle pruning. The implementation of handle pruning involves the following data structures. It uses a stack, Stack is used to hold the symbols. Stack is used to hold the symbols. And input buffer. The input buffer contains the input and it decides whether to handle the handles. It decides to handles. Okay. In a table, it decides whether to handle or not. Nothing but handle is nothing but whether a substring is matched for the given production or not. If it is matched, it will handle. So nothing but these are the two data structures which are used in the handle pruning. So what is the stack? A stack is used to shift the symbols, nothing but handle the symbols. And next, input buffer contains the string and the handles. So the next is sentential. So what is sentential? A sentential is nothing but it consists of a combination of terminals and non-terminals. Combination of terminals and non-terminals are nothing but A, B, capital S. So this is nothing but a combination of terminals and it is a non-terminal. So that is nothing but sentential. A sentential is nothing but it is a combination of terminals and non-terminals. A derivation is a sequence of replacement of non-terminals using derivation rules given in a grammar. A sentential form is a string over terminals and non-terminals. A sentential form consists of terminals and non-terminals and we are going to derive this sentential form to generate the sentence. See here, S tends to A. Here A is nothing but A is a combination. A is nothing but it is a sentential form. A can be a mix of, it consists of either terminals or non-terminals or a combination of terminals and non-terminals. See here example, S tends to A, S, A, B, S, B, epsilon. So these are nothing but the sententials. These are nothing but sententials. So how we are going to derive it? So what is the given string? This is the sentence. Sentence consists of only terminals. Sentence consists of terminals. Sentential consists of terminals and non-terminals which is present in the rightmost part. Which is present in the rightmost derivation. Okay. So derivation. For example, S tends to A, S, A. And the next what I am going to derive? A. It is a terminal. It is not able to derive. Okay. It's completed. The next I have is S. S I can derive it to BSB or epsilon or this. So let me take the input string as A, B, 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 A. So this is my input string. I need to derive this. So S. So S can be reduced to B, S, B, B, S, B. So A is completed. B is completed. The next again I have B. S can be derived to A, S, A or B, S, B. But again for my input string or from my sentence, I have the symbol B. So I cannot take this one. So I need to take B, S, B. So B, S, I am B. So these B is also completed. The next one more B is there. So again I am going to derive this. Yes, it is completed. I got 4. And now I can derive it with epsilon. So what I am getting? A, B, B, epsilon. Epsilon is nothing but empty. Nothing is there. Next B, B and A. See here, A, B, B, epsilon, B, B, A. So what I can write epsilon by removing A, B, 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 A. So this is the string it generated. This is the string it generated. So this is nothing but sentence. This is it is nothing but sentence. So it is nothing but a sentence. A sentential form consisting of terminals or non-terminals. So the sentential form is divided into two types, left sentential form and right sentential form. So the left sentential form occurs in the leftmost derivation of some sentences. Right sentential form occurs in the rightmost derivation. Nothing but we are going to expand the rightmost terminals. We are going to expand the rightmost non-terminals are going to be expanded. So that is nothing but right sentential. Coming to the left sentential, we are going to expand the leftmost terminals. Leftmost productions we are going to expand. Coming to right sentential, we are going to expand rightmost terminals. Rightmost productions we are going to expand until I get a sentence. So here we are going to use mainly the right sentential form in handles and pruning. In handle pruning, we are going to use right sentential form. In bottom-up parser, we are going to use right sentential form. So let us see one example. Example for right sentential form and handle for the grammar. So this is my grammar. A grammar consists of productions. So these are the three columns we are going to take. First one is right sentential. The next one is handle, and next we are going to have reduce production. So what is the input string I am going to have? ID plus ID into ID is my input string. Okay, so what is this handle? Handle is nothing but we are going to check whether the substring is matching to the production or not in the rightmost derivation. If it is matching, we are going to reduce that. So the what is, if it is following the leftmost derivation, we are going to start from the left. From left we are going to start. So what is the first symbol I am having? ID. So what handle is doing? Handle is handling the ID. It checks ID is present in my rightmost derivation. Yes, it is found. So then replace these rightmost derivation with the leftmost non-terminal. Replace it with the leftmost non-terminal. So what is the leftmost non-terminal? E tends to ID. So nothing but the terminal is reduced to the non-terminal. We are going to reduce it to the non-terminal. So that is written in the reduce production. So now ID is replaced with E. It is replaced. So the next what I am having, E plus is completed. The next what I am having, ID. Again it handles ID. And again it is replacing it with E tends to ID. Then nothing but it comes here and it replaces it with E. E plus E. Next what I am having, ID. Again it handles, again it replaces with it E plus E into E. Okay. So the next what I am having, again it checks whether any handles are there. Even I get the non-terminals, again I can check whether these non-terminals are present in the rightmost derivation of a production. If it is found, replace that rightmost derivation with the leftmost. So this is also a substring. I complete. Next it checks E plus E. First it checks E plus. It is there, it is not there. Then it checks for it takes next input symbol, E plus E. Either it is found E plus E, yes. So handles, E plus E is handle. And it is reduced to E tends to E plus E. So this is replaced with E. E star E. Check whether E star E can be handled. Yes, it is found in my production. So then I am writing E star E and replace that with E. So that is reduced and written here E. So this is nothing but it is following a right sentential form because we are going to apply rightmost derivation. We are going to apply rightmost derivation, nothing but we are going to expand the rightmost symbols. So this is nothing but handle. Coming to the handle pruning. What we have discussed handle pruning, it is nothing but we are going to apply it in a reverse manner by applying rightmost derivation. Let me check what I can write. The last one is E. Then I am going to derive E star E. E star E is completed. The next what I have here, E star E. Next E star, it is completed. Then next it is replaced with E plus E. E plus E, it is completed. The next last E is derived to ID. See here, I am applying the rightmost derivation, not the leftmost derivation, ID. Then after the next E is reduced, ID, next E is reduced. The next, in the next phase what I am going to have, ID is reduced. So nothing but ID plus ID star ID. ID plus ID star ID. So this is nothing but handle pruning. We are going to apply in the reverse manner by applying rightmost derivation. So that is nothing but handle pruning. Handle is nothing but we are going to check whether the substring is matching in my production. If it is matching, then we are going to replace that handle by the left non-terminal. by replacing that with the left non-terminal. That is nothing but reduction or reduce production. So one more example. Here I have taken, in the previous example, ID plus ID into ID. Here I am taking ID, ID plus ID plus ID. So see here. First what I am having the symbol ID. Here even though I am applying the left procedure, left sentential, nothing but leftmost derivation. The reading is done from the left. ID. It handles ID. ID is handle. So it can be replaced it with E. E tends to ID. So that is ID is replaced with non-terminal, leftmost non-terminal. The next what I am having substring ID. Check whether it is there. Yes. So I can handle it. ID. And check whether it is there. Yes. So replace it with ID. So it can be replaced. E plus E. The next handle ID. It can be replaced with E tends to ID. So I am going to get E plus E plus E. Check whether E plus E is there or not. Yes, it is there. So check. E plus E is there. These two first E's I need to check. E plus E. Yes, it is there. So it can be replaced it with E. So it can be replaced it with E. It checks E plus E. It is there. So it replaces it with E. Even we apply. So nothing but whenever I am going to handle and when I am going to reduce the production, it should generate compulsory the start symbol. Then only we can say that the string is correct. The syntax of tokens are correct. If it is correct, then only it generates a parse tree. If the syntax of the tokens are wrong, or if we are not going to take any particular correct production, we are not replacing it with the correct production, then it won't generate the parse tree. If it is not generating the parse tree, is nothing but the given syntax is wrong. So we need to check whether that production is available in my grammar. If it is available in the next further steps, then only we can replace it. So this is one more grammar for using right sentential form. So today what we have discussed, what is handle pruning, and what is sentential. There are two types, left sentential, right sentential, and how we are going to apply this handle pruning using the left sentential with an example we have discussed. Thank you.